This is just going to be a quick reminder video on how to use your solubility rules from your little star reference chart. If you just look it up online, you can find other solubility rules charts. Most of them work pretty much the same way, but I think the keywords are kind of still the same. So I'm just going to kind of point out, this is on the inside of your star chart. If you brought yours home with you, if you did not, I'll be posting another one onto Google Classroom that you could just kind of reference, keep it in your tabs. But looking here, we have our list of anions. And so remember, an anion is the second thing listed in a compound. So if I have something like, let's just do something easy real quick. Let's just do sodium chloride, right? We're looking at this part. The only exception to that is ammonium, where you could have ammonium chloride, right? And so then we're looking at this part or that part, whichever. So that's the only exception in our whole list. But once you figure out who you've got, so we have chlorine in both of these, right? So chlorine is down here. Chlorine is under the soluble list. Remember, the state of matter that we associate with soluble is going to be aqueous. Okay, aqueous, meaning it's dissolvable. Okay, it's in solution. It's a homogeneous mixture. Okay, so it's soluble unless, so you say that word out loud. That's what we kind of practiced in class, right? Unless it's with compounds of silver, lead, or mercury. So if it's with one of those, it's no longer going to be aqueous. Now it's going to be a solid, right? So for this first example that I wrote up here, it obviously does not contain one of those, so therefore it would be aqueous. So sodium chloride would be labeled as aqueous in our little double replacement. So if you've started some of the extra credit, this might be useful to you. The other part of our list is the insoluble list. So if your anion that you're looking at falls into this list, you're going to basically, you're going to now state that they are solid, not soluble, but solid, meaning insoluble. This is usually where your precipitate comes from. Okay, so this is usually labeling the precipitate if it ends up as an insoluble or under the exceptions list over here. Okay, and so if it falls under here, it is solid, it is not soluble unless it's with, and we have these little things listed off on the right. Okay, so this will now make these aqueous. Okay, so remember your alkali metals are just group 1s. Okay, and so I would say the big picture here is that up top we have aqueous unless, and then it turns into a solid. So if it falls under that list, down here we have solid unless this makes it aqueous. Okay, so that's how you're going to be using this little chart. Let me run through at least a couple examples from the page that was just posted today. And this is not an assignment that you need to turn in today or anything. It's just something to maybe get you started on, because tomorrow you will possibly be submitting a few of these answers to me. Okay, so to start you off, let's do a couple of the even numbers. Okay, so I've got barium hydroxide right here. I totally gave that away. You also need to be practicing your naming. So you notice that we have a polyatomic, so just a reminder of where all that information is. They are right here on this little list, your polyatomics, right up here, okay? All right, but back to our solubility. So we would figure out hydroxide. Hydroxide is way down here. So hydroxide is insoluble, or it's a solid, unless it's with, and now we're going to look at who it's with. It's with barium, okay? So looking across, we have our compounds. We have our compounds of ammonia and alkali metals. Let me keep zooming out. I'm so sorry. Okay, yeah. We have our alkali metals or ammonium and we call this castrober, but it's calcium, strontium, or barium, right? If it has one of those things, somebody from group 1, ammonium, or any calcium, strontium, or barium, now we just turn to aqueous. So your answer for this one would then be that it's soluble. And up here, I kind of noted that I want you to put aqueous, and then for insoluble, you can put a solid. Okay, if you do decide to do insoluble and soluble, make sure you're noting that that's how you're writing it. Okay, so this one is going to be aqueous, all right, or soluble, all right. Okay, so another one. Let's look at one like number 11. So we're gonna do one like this. So we have bromine. Okay, so bromine is up here. So we have it right here for us. Okay, I'm gonna shrink our paper out of the way. Hold on. Okay, so we have bromine up here. Bromine is under the soluble list, so now we're under this list, okay? Unless it's with silver, lead, or mercury. So looking at your worksheet again, okay, we have silver and it's with bromine. Sorry, we have bromine and it's with silver. So therefore, we actually have our precipitate here. So this one is going to be a solid. Okay, so like I said, you can either go down the list and do soluble, insoluble, or you can do aqueous, solid. But you gotta pick one or the other. Otherwise, all your S's are gonna be whatever they are. So, or write the words out. So this one was silver bromide. We don't have to indicate that it's a 1 because silver is always gonna be a 1. So go ahead and give this worksheet a try. Like I said, I'm probably going to ask you for a few of these numbers tomorrow to just submit. And so if you'd like to just wait till tomorrow, you could. But if it were me, I would kind of, this should be just a review. So I would knock out these answers, practice a little bit of the naming. I don't mind posting the naming later, definitely to help you with that. I know that was something that a lot of us struggled with. So but do your best. You don't need the names to figure out your solubility. So at least get the solubility down because that's what this whole section is about. All right, so until tomorrow. Let me know if you have any questions though.